this is a continuation of the meiosis modeling. We need to maybe draw what's happening in each stage so that we have some notes to look back on. So remember, in prophase 1, your homologous chromosomes get really, really close. They actually cross over, exchange genes, exchange DNA. So it leads to some great genetic diversity. So if we were going to draw prophase 1, so we're starting to make our spindle. Big chromosome. And I've got my blue one. And I've got my blue. And then to demonstrate crossing over, after crossing over, my chromosomes are going to look like this. This is going to be unchanged. This is happening. Okay, so these have remained unchanged. There's no crossing over here. Once they're done crossing over, you have this one that's mostly blue with a little bit of green DNA. This one's mostly green with a little blue DNA. All right, now we're ready to do metaphase 1. So here's metaphase. These chromosomes are going to line up at the equator. So, and here's its homologous pair. And then you have this one. A little green. And this one is green with a little bit of blue. We have our spindle. And this is metaphase Roman numeral 1. All right, moving on to anaphase 1. Here's my cell. My spindle fibers are getting short. So my little bitty blue chromosome gets pulled up here. My big chromosome that's mostly blue, that's got a little bit of green on it, gets pulled up here also. My chromosome that's all green here gets pulled down here. My chromosome that's mostly green with a little bit of blue gets pulled down here. And this is anaphase. Now, anaphase gets done. This is going to pinch in, this is going to pinch in, producing 2 separate cells. So telophase 1 is going to give us 2 cells. This cell looks like that, and this cell looks like that. Okay, remember we said that there are 2 chromosomes in each cell, and this is haploid because you only have the left shoe. You only have the left shoe. Here you only have the right van. Here you have the right croc. Over here you have the left croc, the left van. 2 different shoes. Get it? Analogy? Okay, all right. Now, at this point in metaphase 1, as we emphasized with the Play-Doh, these didn't have to line up like this. You could have the green on top and the blue on the bottom, and that would have led to additional genetic diversity. So that was meiosis 1. Now we're ready to move on to meiosis 2. Between telophase 1 and prophase 2, there's a stage called interkinesis, and that's just a brief resting stage. The DNA is in the form of chromatin, it's not chromosomes. Now, prophase 2 is going to look a lot like telophase 1. Oh, just kidding. This should be prophase 2. So here I'm going to have my little bitty green and my chromosome that's mostly green with a little bit of blue. And over here I'm going to have my little blue one and my chromosome that's mostly blue with a little bit of green. All right, we're ready to do metaphase 1. I'm sorry, metaphase 2. Metaphase 2. Metaphase 2. Here's a cell over here. Here's a cell over here. That's spindle forming. Spindle, 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 spindle. All right, my sister chromatids go to the equator. Over here, my sister chromatids go to the equator. There they are. 2 cells, metaphase 2. Anaphase 2. We still have 2 cells. Here's a cell. Here's a cell. But my spindle fibers are shortening. So when my spindle fibers shorten, that's going to pull apart these sister chromatids. So this side gets the completely blue chromosomes. This side gets the blue chromosome with a little bit of green. This side gets the green chromosome. This side gets the green chromosome with a little bit of blue. Okay. So now we're ready for telophase 2. Okay. Again, this is a process. This cleavage furrow is going to start forming. It's going to start pinching in here at the equator. Eventually, so here we have all blue, little bitty blue, little bitty blue, with the green end, little bitty green, big green, little bitty green, green, with the blue end. So this eventually completely closes off, So we end up with 1, 2, 3, 4 cells, and they are completely genetically unique. So meiosis, we copied the DNA once, but we divided the DNA twice. The end result is 4 cells that are genetically unique. 2 reasons for them being genetically unique. First of all, in prophase 1, we crossed over, the chromosomes crossed over. And the other reason for them to be genetically unique is in metaphase 1, how these guys lined up here, because they would have been totally different if this had been green on top and blue on bottom.